Hello everyone. Today we are going to discuss about certain topics on CE8395 Strength of Materials for Mechanical Engineers. Anna University framed syllabus of 5 units, and now we are going to see about topics on Unit 1 Stress, Strain and Deformation of Solids, and the syllabus in the Unit 1 covers rigid bodies and deformable solids, tension, compression and shear stresses, deformation of simple and compound bars, thermal stresses, elastic constants, volumetric strain, stresses on inclined planes, principal stresses and principal planes. The last one is Mohr circle of stress. So introduction. So now we are going to see about what is meant by the strength of materials. So when an external force acts on a body, the body tends to undergo some deformation. Due to cohesion between the molecules, the body resists deformation. This resistance by which material of the body opposes the deformation is known as strength of materials. So from these 3 points we can able to understand that whenever an external force acts on a body, that body will resist the force what we are applying, and that is known as strength of material. So within a certain limit, that is in the elastic stage or elastic range, the resistance offered by the material is proportional to the deformation brought out on the material by external force, which is nothing but Hooke's law. So within elastic limit, stress is directly proportional to strain. That's it. Also, within this limit, the resistance is equal to the external force or applied load. But beyond the elastic stage, the resistance offered by the material is less than the applied load, which means beyond the elastic stage, that is in the plastic region, plasticity, the resistance offered by the material will be less than the applied load. In such a case, the deformation continues until failure takes place. Within elastic stage, the resistance force equals applied load. This resistance force per unit area is called stress or intensity of stress. Next, the important parameter is how we can apply the force on a body by means of loads. So what are all the types of loads available? In the mechanics of deformable bodies, the following types of loads are commonly considered. What are they? They are dead loads, that is static in nature, such as self weight of the roof. Since every body, every object has its own weight, that we can already know. Live loads, fluctuating in nature, do not remain constant, such as weight of a vehicle moving on a bridge, which is nothing but live loads. And then tensile loads, compressive loads, shearing loads. Depending on the nature of the forces mentioned, the stress can be called the tensile stress or the compressive stress. The tensile stress is induced when the applied force has pulling effect on the body. Generally, the tensile stress is considered positive. The compressive stress. Compressive stress is induced when the applied load has pushing effect towards a point. Generally, compressive stress is considered negative, which means the object will get shrinked when we apply a compressive load. On the other hand, the shearing stress is induced when the applied load is parallel to or tangent to the surface. So from this table and from this figure, we can able to understand what is meant by tensile load, what is meant by compressive load, and what is meant by shearing load. So the stress will be tensile for tensile load and strain will be tensile for tensile, which means when we are applying tensile load, the stress we will obtain is tensile stress and the strain we will be getting as tensile strain. Similarly for compressive load and for shearing load. And this image we can able to understand that the tensile load is applied on either ends of the object equal and opposite in direction. And in case of compressive, the load will be applied on against the directions on the either hand. And shearing equal and opposite in a plane. And then these are all the loads that we had seen in the up to the previous slide, and now we are going to see about the materials and its classification. Since strength of materials includes all these parameters: loads, stress, strain, materials, etc. So from an engineering point of view, the properties concerned with metals are 5 major properties. They are elasticity, plasticity, brittleness, malleability, and then ductility. Many of these properties are contrasting in nature, so that a given metal cannot exhibit simultaneously all these properties, which means an engineering material may be comprised of any of these properties but not all of these properties. For example, mild steel exhibits the property of elasticity, copper possesses the property of ductility, and then rough iron is malleable. Lead is plastic and cast iron is brittle. So all these kind of properties will be understood from these examples. So elastic material. Material undergoes a deformation when subjected to an external loading such that deformation disappears on the removal of the loading. Example is rubber. So elastic material is nothing but, and rubber band is also another example for this elastic material. So when we expand the rubber by giving a force, and when we are removing that force, that elastic rubber band will regain its original shape. That's the example for elastic material. And then plastic material. It undergoes a continuous deformation during the period of loading, and the deformation is permanent. It does not regain its original dimensions on the removal of the loading. Example, aluminium. So when we applied a force, the deformation continues or in progress, which means it does not regain its original shape even after the removal of load we had applied. And then rigid material. It does not undergo any deformation when subjected to an external loading. Glass and cast iron is an example. So this is an example for rigid material. It does not undergo any deformation. So whatever the force we are applying, the material will not respond. And then malleability. Material's ability to be hammered out into thin sheets, such as lead is called malleability. So lead is an example for this malleability property, which means it can be hammered to get our desired shape. And the last one is brittle material. They exhibit relatively small extensions to fracture, such as glass and cast iron. There is little or no necking and fracture for brittle materials, which means the deformation when applying load cannot be visually seen, but we can see that the material will get failure all of a sudden when we are applying a force. Stress. So the definition of stress will be, it is an internal resistance offered by a unit area of the material. from which a member is made to an externally applied load. Alternatively, the force per unit area that can be visually seen in the figure, or intensity of the forces distributed over a given section, is called the stress on that section. The resistance of material or the internal force acting on a unit area may act in any direction. So stress is nothing but applied load to the original cross section area resisting the force, which can be denoted as, in the symbol, sigma is equal to P by A. And then what are all the types of stresses? Commonly tensile stress, compressive stress, and then shear stress. So the stress may be normal stress or a shear stress. So normal stress is nothing but the combination of tensile and compressive. So it is represented as sigma. The normal stress is further given to tensile stress and then compressive stress. So consider this as an object and the load is applied on either direction. Tensile, which means opposite in directions. So the resistance at the cross section will be also in opposite. So for this P applied load, the resistance will be this side, and for this the resistance will be on left hand side. So while combining the object, we will be getting that the resistance, and that can be clearly stated as internal resistance on applying a force P, force or load, whatever P, the internal resistance will be like this at the cross section. Compressive stress, the stress induced on a body when subjected to two equal and opposite pushes. In the previous slide we are seeing that the applied load will be on opposite in direction, but in this compressive stress the load will be pushing towards the cross section. As a result of applied compressive stress, there will be compressive strain, which means the change of dimensions, and that can be denoted as dl by L, which means decrease in length by original length. In case of tensile stress, the formula will be the same, dl by L, but increase in length by original length there will be in tensile stress. Shear stress. Shear stress induced in a body when subjected to two equal and opposite forces. This is the important parameter we should understand. Two equal and opposite forces which are acting tangentially. The condition is tangentially across the resisting action as shown in figure, as a result of which the body tends to shear off across the section is known as shear stress. So that we can see that the gap in the first image before applying the load, that is shear load, and after applied the shear load, the object will be seen as like this. It gets sheared, which means it gets deformed. So the corresponding strain is known as shear stress, shear strain. The shear stress is the stress which acts tangentially to the area. It is represented as tau. The symbol or denotation for shear stress is tau. So strain. So as a result of the applying load stress, the strain will be obtained. So what are all the strain? When we applying tensile stress, the strain will be tensile strain, and similarly for compressive, and then for volumetric, and then shear. So if there is some increase in length due to external force, and then the ratio of increase in length to the original length is tensile strain. In case of decrease in length to the original length due to the applied compressive stress, the strain will be compressive strain. and the ratio of change of volume of the body to the original volume is volumetric strain, and similarly the strain produced by shear stress is shear strain. So linear strain is nothing but the tensile strain and compressive strain is combinedly known as linear strain. Change in length by original length. Either increase in length to the original length, that will be tensile. Decrease in length to the original length, that will be compressive. So both are linear strain. Change in length by original length is termed as strain. And whereas in the case of member of variable cross section, however, the normal stress sigma is equal to P by A, varies along the member, and it is necessary to define the strain at a given point. So in case of variable cross section of member, the strain will be related as E is equal to limit del x to 0 del of change in length. This symbol represents del, change in length, divided by del of x is equal to d of change in length by dx, which means differentiation of change in length. That is the strain in case of variable cross section member. And then shear strain. So it is a measure of angle through which a body is deformed by the applied force, denoted by gamma. The symbol denotation for shear strain is gamma. The shear strain is represented by the angle through which the other two faces have rotated as shown in figure. So this angle gamma of xy due to shearing force, when AD is applied towards left hand side and BC is applied towards right hand side of force, the resultant image will be like this. So this difference in angle is known as shear strain, and it is represented as gamma. And in case of volumetric strain, the ratio of change in volume of the body to the original volume is known as volumetric strain. So thank you. So I had compiled some of the parameters which is very important to the unit 1 stress, strain and deformation of solids in the paper strength of materials for mechanical engineers. So we get seen all these types of loads, types of stresses, types of strain and the engineering materials. These are all the basics for this paper strength of materials for mechanical engineers. Thank you.